Hello, Dr. Mike here. This is from my CIS 2640 Network Security / Security Plus course, and it is topic 5. At the time of this recording, this is our current textbook, and it is chapter 9 and 10, Attacks and Network Attacks. I will link to a video above on the previous textbook with the same topics. You can go and watch that if you like. It might cover areas I might not cover here, but it should be the same material. So let's jump into it. So chapter 9, attacks. Chapter 9 definitely starts off with a good point here, which is targets of opportunity. So in Security Plus, I know we like to, you definitely got to, in being defense, you got to think like the attacker. And this is why we learn the tools of the trade and also the thought process. And you don't just attack the company or you don't really target the computer, you target the people behind the computer. So when looking at something called an attack chain or an attack tree getting built, these targets can be almost anything. And we'll see this as a very effective attack, which we've currently seen before, which is phishing, which can then help install things like ransomware, which we know has caused huge issues. So look at your target opportunity. And we'll look at some tools for that. I'll actually demo some tools for that. So we'll look at the textbook. I'll have some stuff I'm going to show you it's not in the textbook. I think it was of a value to definitely look at. So stay tuned for those. And also think of the attack. Why? Is it monetary? Is it political? If you're with a company that can cause some sort of political strife, you could become a target of an advanced persistent threat, an APT. That could be a huge issue. It's hard to defend against an APT. A lot of times it's monetary. This is really probably what it is. And it's a monetary, we can look at that as, yes, money, ransomware. Pay me money, pay me Bitcoin. Or it could be data. That data could be worth value on the dark web. So extracting data. And it actually someone could be hired to get several aspects of your company. It could be corporate information, top secret information, investment information, things like that. So you need to think about where those things are at in the company and how people can get to them, the attacker can get to them. So one of the best ways is reconnaissance. This is probably the biggest step here. You can see here, this is part of a larger attack tree. In the figure 9.1 here, they show the steps of attack, which is recon, scan, vulnerabilities, cover tracks. Recon and scan and research vulnerabilities. Those three things you can do as a defender, and you should do. You should run these same tools. And there's lots of tools for this. I'm not going to get into all of the tools. I'll show you one tool. That's probably one of the most beneficial one that can do both recon, scan, and help you with vulnerability searching. So again, Nessus, there's OWASP, Zap, there's web-based tools, there's just a large amount of tools. And but I'll show you one here, and probably the best one is Nmap. So Nmap is fantastic. Nmap.org. It's free and installs and runs on Mac, Linux, Windows. It's a fantastic utility. There's a GUI for it, a ZenMap GUI that I know during my course you'll either have already run probably at this point or will run. And Nmap itself, so I set up here a lab. I have Kali Linux here, and I have Metasploitable 2 Linux running in a VM here. It's on 184.2. So a simple scan Nmap in the target. And you can also put in I can put in like nmap/0/24. That's probably what you would do with a quick scan. You do a broader search. And what we're doing is we're setting up ourselves here. Here we are. And we're going to scan a large portion of network. So the 0 to 24, right? 0 to 24 is 0 to 255. That's what the /24 does. Of the 192.168 yada yada network. I'm not going to put that there. So we can scan all that with a quick scan. Something an attacker probably would do. Something that you should do as a defender. Now, of course, you can also scan an individual target. And from that scan, we get back open ports, port number, what's running, and the service. So right away, I can do a quick validation. I can hit this against a server. If I'm a server admin, I can scan my server from a desktop, laptop, and see what's open. And this is part of the server hardening, which I think we go to in more in depth in the course here. But it's good, sort of a good quick way to see what's open. And then you go, wait a minute, why is why are we running Telnet? First question I would come up with. You're like, why are you running that? Why is that open? And a lot of times we see configuration issues. It's not malicious in nature, it's just it was missed in configuration. Maybe it was open previously, and that has been part of the baseline that has been provisioned ever since. Usually servers are provisioned from a baseline or an image, and that has never been taken care of. Maybe in the past it was needed, and maybe it's not anymore. So you should question these things. Why do we have this open? And let's say, well, we're a web server. We need to have that open, and we need to have this open. But why do we need to have VNC open? And so if you go through, you question, you close, address these, you can also then run this scan each time and really pipe this to a text file and do a diff. You can do this for a bunch of servers. You can set up your own script to do a simple scan and you say, wait a minute, why now? Suddenly one server has got a port open that wasn't open before. Set off an alarm, show me even the diff. So of course, this is stuff that you can get in commercial tools, but again, you can start with a homegrown scripted scanner. But that's the first look at here. Now, the second extension of this is when it becomes more powerful, is we attach that SV here. Now, again, look at the guidebook. I'm not going to go over all the Nmap stuff. There's a lot of it. I do suggest having a cheat sheet. But the service version scan, that's why I remember it as -SV. When I attach that, I get back not just the port numbers that are open, I also get the version numbers. Now this version number info, going back, again, think like for an attacker. This is of huge value. And so a lot of times you'll either want to find to obscure these or not post them at all. And we see something with defense called a web app firewall, a WAF. A lot of times anti-DDoS companies like FireEye and stuff will actually provide this, even down to firewalls within the company. A lot of times when you hit a WAF, I've done this before in my pen testing, I will come back with all the ports are open and they don't show anything. I get all 65K ports or they all show closed. They're open or they're closed, and then there's nothing. That's it. There's no... you basically just given a big block of unusable information. So a web app firewall will do that, and then also beyond that, will control what can go in and out. So I'm not going to get into firewall technology here, but I want you to know that if you do run this, and you run it against Nmap, an actual domain name, you might get everything back. You might get nothing back. And if you're a defender, it's a good sign. That means your web app firewall is working correctly. You want to find that chink in the armor. You want to find it before an attacker does. Now, if you don't have the luxury of having this, having a web app firewall running, and you just open like this, and you're displaying version information, this is of huge value. If it's correct information, you can see I can take this version here, VSFTP 2.3.4, and I can go to exploit.db, type it in, and go, look, there's actually a backdoor for that. Click on that right there, and it's actually a Metasploit package, which that's what that means right here. And this is for exploit.db. I can go here and I can see the actual demo code for it. And even better, I can go into Metasploit. I can do a search for VSFTP. I can find that exploit, that backdoor exploit, which is really old by now. Don't let that say, well, it's an old exploit. They may not have that patched. Don't ever assume that. Always check. And I can take this exploit, actually load it, which I did here. I actually use the exploit. I can basically just do a set here. You can see the information on it. It's the exploit, it's Unix. I can set basically my rhost to this IP address and fire away, and I might get breach in, I might be able to get in. So I looked at the attack chain here, and basically that's what we did. We took the attack chain from the search of Nmap, and we extended it out. It does that. Expand. There we go. And we expanded it out, and we can actually find an attack. And this is what an attacker will probably do. And as a defender, you should do the same thing. You should be looking for this type of information, what's being emitted out, not just outside your internet, your home network, within the network too. Don't assume all attackers are coming from external. So yeah, maybe from external you don't see it, but if an attacker does get a foothold, maybe within the DMZ, and they scan, does it look different? So you need to assume the attacker is within the network, and Nmap's going to help you do that. All right, so now beyond this, of course, we looked at researching vulnerabilities. We just sort of did that right there. We just did the scan, recon, scan, look at the vulnerabilities. Cover tracks, of course, that's something that they would do. You want to put things in place to help prevent this. One of the biggest ones is your logging. And usually use some sort of rsyslog, remote syslog, or a logging server, which is not uncommon today. All that is, I have several servers, maybe in the cloud, maybe on site, on premise. And then, of course, they have their own log files. And log files are essential, not just for seeing who attacked us and how, but also, if the system goes down, any type of issues, right? Application issues, operating system issues. This is what we use to sort of forensically see what happened. How come it died? Well, also we look at it for, look at load analysis, traffic analysis. Maybe these are web servers. So this bank of web servers here, I don't want to do the analysis on the server, right? I want to save all the CPU resources. So a lot of times you will use something called an rsyslog in Linux, or some other remote logging. And you have a log server. Using internal, it gets a copy of the logs, and usually immutable. So you can't, since it's written here, it's a immutable copy. And those can be copied off onto analysis servers where you run like Python or all sorts of open and commercial logging software that will give you those cool dashboards, how things are running. And this is what we see on DevSecOps. We see those big dashboards with pie charts and line charts. How's our network traffic looking? How's our CPU use looking? Alert boxes going off. And it's alert boxes for anything, right? Hey, maybe the memory's bad on this server right here. This same infrastructure that's used for this can be used to help prevent covering tracks, because there's a immutable copy of this log here. As soon as someone logs in and you start doing stuff, they go back, they could log off here, but the log remains here. And that can be pulled off for forensic analysis. So it's a good way to have that. Should be part of that system. And so let's go look at research vulnerabilities. I'm going to add one more thing here, and that is with, of course, Nmap. Now, Nmap is, we look at Nmap before we say we can see, exploits. We look at the version. We can look for the exploits. Nmap also has something called vulners and scripting. So there's actually vulners, Nmap vulners here. So look for Nmap-vulners, and usually you can find this on GitHub. And what you load in, and mine's a little out of date here, but you load in a up-to-date mini CVSS database of current issues. And this is some examples on here. Now I ran this against Metasploitable, which of course has got a ton of issues. You can see here it's an SV, but then I also added the script, -- script. Scripting in Nmap is fantastic. There's tons of stuff here. I did a vulner script, and I passed in the argument 5.0 mini CVSS, which I do have downloaded, and then this is my target, which is of course Metasploitable 2, which we've seen used here and here. So, and what I get, look at this, a ton of stuff. Let's look at port 22. It's OpenSSH. There it says there's all these possible vulnerabilities. And you notice that this does not show anything for VSFTP. Now, this could be the database I'm running against. This doesn't have it. It could be aged out. So you can see where this type of just manually looking through, if you need to have FTP open, is this version? Google that version. Are we up to the right version? If we're not, why not? And is it patched? But also we can run this, of course, and say, well, there's an exploit here, and it actually gives me CVE links, CVE number, and a link. Now this is a huge thing here. Now, of course, as an attacker, I run this against my target, the same as you would as a defender. Now, the problem is you might get a lot of noise here. Sometimes this might be a possible thing here. It's because it might not know the version. If the version's obscured, it might give you a ton of lists of just, here's all the CVEs for this OpenSSH, because we don't know the exact version. So as an attacker, this is where if you can obscure the version number, it really makes this useless. But if you do have bright version numbers here, I can actually look at this here, and I can look at this export. There's a packet storm vulners link here, so and actually give me the attack information here. I actually get it's like memory exhaustion attack. I actually can get some proof of concept code to use. It might have links to the CVE itself, and of course the CVE number is what you need. Just Google the CVE number. And of course, anything that's really old, it should be of concern, because if we're missing a patch somewhere, we're leaving these things open. So, and there's options where you can export this to, and you look at this information, of course, in the vulner site. They give all kinds of information here about usage itself, and you can set it up through here, and so on. So again, Nmap vulners, it's basically, we've gone from just a simple network scanner to a little more in-depth scanner to an actual vulnerability scanner. Now, I always suggest don't use this as your only vulnerability scanner. You should have other stuff in place here. But in any case, Nmap is fantastic, and for a free tool, you really can't beat it. So this is it. This is the thing. We don't look at all research, all evidence of attack, right? And for defense, patching, of course, is huge. Limit the services being run on the system. This is what Nmap helps us do. And limit the amount of publicly available data about the system. Now let's talk about that last point there. Now, of course, we see version information. I mean, I need to run SSH. Do I need to post the version information in my Nmap output? Can I obscure that somehow? Can I run a web app firewall like I talked about? Something to sort of obscure that information, make the attack hard to do. But also publicly available data. Let's talk about that. So there's something here we're going to look at, and we've all used before, and it's your friend. It is Google. Don't discount Google. Now this is a Wikipedia. There's tools for Google hacking. It's usually called Google dorking. I know that's what it's called. That's a great name. Google itself has got some great ways to show, say, hey, give me this site, wikipedia.org. So site : related : cache : in text : so on. File type, PDF. So I can combine these together and say, okay, site : my target domain name, space, file type, PDF, file type .doc. And you tell yourself, well, is this a big deal? What happens if I see all the documents posted from my target? Well, maybe one off, maybe they're documents that weren't supposed to be publicly available, that were scanned. Second off, maybe those public documents can get information that can use in other attacks. Names, email addresses, phone numbers, maybe even the version number, the metadata from the document itself. What version of Office am I running? Is it exposing the version of some Adobe suite software they use to create something? And do those versions have known issues? Or if they're running some sort of blogging software, is that somehow being exposed? So Google dorking. That really is a fantastic way to do this. So, and I'm going to show you one more here. Besides Google dorking, we have, of course, open things called like Shodan. Shodan, it's a free account. I have one myself here. I use it to scan my attackers down. I'm sorry, while I'm attacking, the attackers use it to scan you down. I use it to scan my target down during pen testing. And of course, it could be internal testing too. Go out, use these external tools, and see what is exposed about your company. And there's all kinds of hints here. A lot of times you just put the IP address in or even just the domain name in. But you could put in some filters here. And here's some cheat sheets here. Here's an example. These are for Google. If I wanted to, I could put in maybe let's like org Sinclair edu and run that against it. And the hope is what's out here, as Shodan's found, in this case nothing, which is probably good, or let's try lowercase Sinclair edu. What's out here, you want to make sure what's out here is supposed to be out here. So first off, 11 results, 443, that's not too bad, but there's some port 80s. Okay, well, port 80 we know is unsecure HTTP. That still might be all right, but maybe it's not. So you want to make sure that whatever Shodan has found is either maybe aged and has now been resolved. In this case, I can find some document stuff here on my Aero Systems login screen. And so port 80, I get the information. Look at the raw data view if I want. But so again, we can use this Shodan to search for what Shodan's already scraped. Anything about your target that's publicly available. So again, let's go back and look at that. And that really is using this public available data. That is a huge thing. You want to see that from your as a defender and use that as an attacker. So, all right. So other places to look: Pastebin, GitHub searches, code comments. Maybe I actually go to my attacker's webpage, pull down the raw HTML, and this script through comments. You might be surprised at the kind of stuff that was put in there from the developer side. Maybe it could be test logins that were used that were never removed. It could be, worst case, API keys for the cloud system you're using that weren't supposed to be exposed. That is also the same thing on GitHub. You don't want GitHub to be open. If GitHub is open, what's out there should not, of course, you shouldn't have any. It should be publicly available code. Maybe it's a open source project you're a part of, your company's part of. You don't want anything dangerous in that code base. So a GitHub search, and then you get into the whole dark web searching, which is really a pain, but you can also search the dark web for your company and or you or whatever your target is. So you can use this information in an attack. I showed you before, we looked at VSFTP. We know there's code flaws. We know there's an actual exploit already. We can use that or use it in phishing. I could, now let's say, go through, find my attacker. I'm the attacker, and I look at my target. Maybe I can go through and get information from their website. Maybe the executive page on the website has got information, metadata on the JPEG images of all their headshots. Maybe in there is information about who took the pictures. Maybe it's a company. So that allows me to maybe I can go ahead and set up an attack as that company, use it for phishing. So you can see where sometimes a benign information like the name of the photographer company that took the headshots for the executives can be used later in a phishing attack. Or information about who your ISP is, your hosting provider. I can use that. I can come across as part of the host provider and then somehow get some kind of email or a phone call or something physical in there. So, it is a huge attack. Phishing is definitely one of the big ones. So, attacks on encryption. I think I showed this before when we looked at the previous demo with like OpenSSL Labs. What type of encryption is being used, and can I opt for the lowest level of encryption? So if I have a website that, or some sort of system that allows me to have lower levels of encryption, an attacker might try to use that because they can use a, of course, 40-bit encryption scheme much easier to hack here than a 256-bit scheme, of course. So is there anything where I have weak encryption in place? That's something you need to look at. SSL is one place to look for that. But also what's being used within the company. Are we following the current standards for encryption, which is talked about in my previous videos for like database, data at rest, data and process, and data being transmitted. So think about the data in those three states. Again, data at rest, data being processed, and data in transmission. How are we protecting that data? Password attacks, probably the biggest one. Passwords are still, next to phishing, passwords are still one of the biggest issues. Weak passwords. I can say one thing here. One of the biggest things to help out is multi-factor authentication. And yes, I know as an individual, people say, well, don't use a SIM card because someone can, possibly, sort of imprint your SIM card on another phone. It is possible. If you're into that level of attack, you're that big of a company, you shouldn't just use SIMs then. You don't use, your SMS. As an individual, even this is better than nothing. Have something, email, SMS. Probably more better is like Google Authenticator or an Authenticator app or some sort of authentication key. Definitely want to have that. I know SMS, you're going to call it in the question and you'll see that in question. Again, as an individual, as a person, it's better than have that than nothing at all. As a corporation, you might want to go in question using SMS. This is going to be your biggest ways to help from password attacks. Biggest one, of course, is, besides that, is just to have a good password policy in place and good enforcement. So I have an administrative principle being a security policy. That's enforceable, but also can be set up technically, so I can have things in place like PAM modules, Linux, Active Directory settings, where I need to enforce strong passwords. So that's definitely the big one to look at. So injection attacks. I'm going to come back to injection attacks here. We're going to talk about this in a little bit. I have something to show you for that, but think about the biggest one is this. SQL injection is probably the biggest attack vector. One of the major ones. Command injection after that. LDAP's not as much, XML not as much, but all these are injection attacks, and it really depends upon the company, your target, your company. It could be anything. Now, a lot of times this is going to come in the form of web page. So anything over HTTP, HTTPS, anything that calls back to a database. And this is, of course, like example, maybe a search on the page, a search field. Maybe I'm searching for employees. So we assume the user is going to put in Smith and all. And if the system itself takes select, a splat from employees where last name equals what the person passed to us, right? We build a SQL statement that way. That's wrong. You don't want to do that. You want to have something called parameterization here. And I'm going to show you some stuff in a little bit here. I think I'm going to talk about that here in the next chapter. But you want ways to protect that, and also the output too. So it's called parameterization or sanitation of inputs and outputs. So really important you look at that. We'll come back to that in a second. I got some good history on that one there. Software exploitation, again, just knowing what you have running and what you have in place. Is there any exploits that are unknown? If it's a 0-day, it's hard to defend against that. So a layered security is a big deal. Don't try to depend on the fact that just we have one piece of software protecting our data. You want that layered protection. So that way, if there's a buffer overflow of one of our pieces of software, maybe we have some encryption behind it that has MFA attached to it, things like that. Malicious code, again, this is usually what comes over either sent via maybe after an injection or maybe a cross-site scripting, or probably the biggest one is phishing. Phishing email, comes in. And a lot of times this is going to come across, we have viruses, Trojan horses, spyware, worms, rootkits, logic bombs. I'm not going to read these to you, they're right there. Look them over. But know that a lot of times this comes in two ways. It's going to come in physically. USB key, one of the biggest ones. Someone brought it in, plugged in something into a corporate network that shouldn't be plugged in. It's going to come over some form of email. And if it comes that way, a lot of times you're not going to have like the old school, which is like, free Amazon gift card.exe. A lot of times that stuff gets scrubbed. One of the biggest attack vectors is the web. And what we'll do is we pass in a phase 1 attack, which here's my attacker. So using the web, I host a phase 1 attack, which might be just a string to load something. And this itself looks very benign. It's just maybe maybe it's just a small statement that runs in JavaScript, for example. And so when it comes across, maybe through email or a web page, so email or over a web page, maybe for cross-site scripting, for example, it's hard to detect. And when someone clicks on it, and maybe they're asked, hey, do you want this to run? And I've done it myself. You get in a hurry, you just click OK. You don't even read the error message. You just click OK. You want to get whatever done. This then goes out and fetches from the attacker the rest of the actual attack code. So here we have the actual virus code itself, and then it gets implanted and it runs on the thing. So this is our phase 2. So we'll see this a lot. Two-phase attacks. You don't ever just like attach your full virus code in your email. It's usually just a small thing to get someone to click and go somewhere. So comes in several phases. Keep that in mind when defending. That's usually how this stuff is delivered. Defense. Talked about already with Nmap. I mean, attacking the system. Attack your own system. Look at your own social engineering. Look at ways the attacker would attack you. Think like the attacker. And then look at defense, not just antivirus, up-to-date software. These are only a few things here. Look at attack trees. How can someone attack to get to our data? Build the attack tree. Look at how someone can use it, and then possibly run the attack yourself. Again, it can be everything as simple as a network scan, Nmap scan, down to look at social engineering, maybe run an actual phishing test within the company. You can hire outside companies to do this, do some phishing testing, find where the training is deficient, find where you're missing policies, both administrative and technical policies that can help shore up your defense. So you gotta almost be on the attack yourself to defend yourself. So social engineering, definitely a big one. This usually combines with phishing, which combines with a network attack. This is why it's all in one attack here. There's a scenario here. I'll just say this. I'll link it up here. There's a great link for a video for a movie called Sneakers. Shows. I'm not gonna get into what the movie is. It's a 90s movie, so it's a little aged. But for a movie, the scene has an attack that's actually great. So both on the social engineering side and also the physical side when it comes to picking locks. So I'll link that up here. If I put in the video here, I'll probably get blocked or I'll get hit by the YouTube authorities. So we move into the network attacks. Now again, this really is an extension of the previous chapter. Where can we be hit? How's our attack tree look? Example, do we have a denial of service attack? So DDoS. A DDoS being several forms. You can ping attack, ping a death, which usually is not too much used anymore. A lot of times you can block pings at your firewall. That's the kind of stuff you can go and test for. But you can do some malformed packets and do a three-way handshake. You can malform it, do a SYN flood, basically sending fake attacks off this way. There's information in the chapter about that. Again, ping and death is not too much anymore, but again, it's because it's old. Don't assume we don't have a weakness for it somewhere. These old things still exist, and they become the weak chinks in the armor. So there are DDoS, anti-DDoS services. Usually combined with when you get that web app firewall, like a FireEye service, for example, and this costs money. So if you have the budget for it, and if DDoSing is something you cannot afford to be down, whereas if you're down for an hour, that could be in the thousands, hundreds of thousands of dollars of lost profit. Take Amazon, for example. So it could be worth the investment to have something like that. If you're not that big, to look at ways to do failover, look at ways to deal with DDoS. And you have your network people involved in this, of course. They'll be the experts at the network side, specifically the public-facing side. Trapdoors, backdoors. I mean, it's more of an attack, but one thing that can be difficult with trapdoors, backdoors, is they can be hard to remove. Now, with good system monitoring, you should be able to notice if someone attaches an account. I will say this, there is something called NCAT, Network Cat, which you can actually use to create a backdoor with NCAT. And you can use it, and it can run in memory. You never actually have to install anything. So, but just be aware of backdoors in all sessions. Sniffing, let's talk about Wi-Fi. And not just Wi-Fi, but any kind of emissions of any kind of network traffic that's wireless. Simple as our buildings here, and here we have a visitor's office where we host, both, not just visitors for the office, friends, family, but also maybe like salespeople, for example. And those people need some sort of Wi-Fi internet access, right? They come to do a sales pitch. This should be first off, should be a secluded network. Second, if it is running Wi-Fi, how far does it extend out of the building? Hopefully it's not attached to the network internally. And also, if we have Wi-Fi for our employees internally, how far does that go out into the parking lot? Are we running a full blast? Do we need to have full blast Wi-Fi available in the last spot in the parking area? I mean, while driving and sniffing, this is a great way to go ahead and sit out here and or even sit just outside the actual property if I can get any type of Wi-Fi devices used to pick up and help pick up weak Wi-Fi and monitor it. And if it is Wi-Fi, what's on it? What type of Wi-Fi are we using? Is it weak Wi-Fi? I hope not. Is it open Wi-Fi? Is it login password? Things like that. So IP spoofing. This come in DOS attacks. Basically, someone pretend to be someone else. So there's these trust relationships we have in place. Biggest thing to see now is this is a zero trust networking. This is a really deep dive into it. I don't know if that talks from the textbook, but zero trust networking. Whereas even within the network of the company, we don't trust anything. So my server does not trust anybody, both externally, any traffic external, or any traffic internal in the company. Traffic coming in and out. I don't trust anything. I need to be able to prove it could be over a PKI type setting where we have a certificate set up. Maybe there's a certificate set up here. I don't use Telnet. I don't use Open. Everything internally is SSH. I assume the attacker is already in the building and monitoring. So the days of the edge protection, which is still needed, I think, in my opinion, is out the door. Yeah, you need to have the DMZ. You need to have the edge protection, to run properly email servers, web servers, and so on. You need to have proper network segmentation, right? I don't want sales to be, my sales to be connected to the HVAC system, or my cashier system, right? HVAC. They should never be able to talk to each other. But even then, even within here, you can still have zero trust networking. So that's actually a topic. It's pretty big. Just think of it that way. You don't trust anything. You assume the attacker's on inside. So something you want to look at. Spoofing and sequence numbers. Okay, so SYNAC, this happens with man-in-the-middle attacks. Man-in-the-middle being someone who comes in and monitors that network traffic. Part of that could be sequence numbering. I can either modify packets while being man in the middle. I can try to replay the attack. It talks about here. I can try to hijack it. And also another thing you want to do is I can look at some things like weak authentication. So I can, if I'm monitoring login information back and forth between two parties, and I notice the session ID is a set fixed number, maybe set off the date timestamp, and maybe it has a set number, maybe it's the user ID, and then like a tick 001, right? So the session ID, if it can be spoofed, that's a horrible look at session ID there. Session ID. If I could monitor, and there's tools for this, but if the session ID is set where it's like a date timestamp, maybe from Zulu time or Greenwich Green time, and then maybe it's the user ID, which, oh God, that's horrible, and then maybe it's like 000, which is 999, right? That's a horrible way to do this. You can literally come out and I can create a new session ID and use it to be that user. Now there's tools for this. One's called I used before in Burp Suite, where it'll just sit there and create a couple thousand logins, and it will actually statistically look for patterns. So you should know, hopefully at your end, it does not come into place. And let's look at some tools for this. So some more tools here for you to look at. Because we looked at already. Look at Shodan already. One of the tools you can have is OWASP. Now, I know I talked about it already. If not, let me introduce you to OWASP, the Open Web Application Security Project. Again, this is those things where we talked about before, NIST, the SP series, things like that. You want to have best practices you can go to. You don't have to start with a blank page. And working in security, on the defending side, you're going to work with developers. And you're going to be like, well, our database is not secure. How do we secure it? Or even better, take the OWASP top 10. So, broken authentication, injection. So we think we have an injection issue. Yeah, talked about injections already in the chapter. So what are they? So if I need to explain what is an injection attack to someone who's not security minded, what does it mean, injection attack? I don't understand. This sort of top 10 will give you this nice little cheat sheets and examples. There's an example here. I can copy paste this. I can give them the link to this. I can maybe explain this in a presentation and explain to a group of developers who maybe are brand new that this is what an injection is. Here's the best part: how to prevent it. What tools do I need to prevent it? What techniques do I use? Primarization, for example, store procedures. Look at your SQL structure, things like that. But even better, here's cheat sheets. So here's a cheat sheet on query primarization. So I can actually give this site to someone who's, okay, now you're talking my language. I'm a Java developer. All right, I understand now. Oh yeah, okay, I know what this is. I've seen this before. I can bring this in, or I'm a .NET developer. Okay, I can bring in, here's my query string. I can use this SQL command parameters, right? And I can sort of parameterize and bring in the code I know to sort of help defend against the attack you're talking about. So this is bridging that gap between the defender and sort of the developer, system admin, you name it. And these cheat sheets are fantastic. Authentication cheat sheets. Man, some of this is pretty straightforward, right? Password strength. Things you don't think about. How we store our passwords. Do we use hashing? Do we use salting? How we transplain stuff. And even better, and this is one I've seen before, here's the types of attacks we can look at: multi-factor authentication, why is it good to use, account lockouts, CAPTCHAs, OAuth, and so on. But even better, this is something that's aside I have to mention. A lot of attacks, or when I do security jobs, I look for password reset. Password reset, a lot of times they'll have a lot of flaws in it. So there's actually a password password storage. There's actually a password reset somewhere in here about salting work factors, but also the best way to do password resets. And it's in here somewhere. I'm not going to dig through it in this presentation. But for example, the old, what's your, the 3 questions. That's the worst thing ever, because we've seen before people have actually been hacked that way. Because the information about the person is immediately available. LinkedIn, social media, it's out there. Again, think like the attacker. I look at the person. I use their information to attack and get in as them. So best time password reset, of course, is the ticketed URL. It's only good for like maybe an hour, or 1 hour, 2 hours, X amount of time. And that URL is only good to only create a new password. It doesn't ever expose the previous password. So, and again, cheat sheets are fantastic. These are the things you want to go to help you sharpen your edge as a defender, and also communicate information out to other folks that are not as well-rounded in security. So OWASP, fantastic. So anyways, that wraps up the chapter. We'll end with OWASP. Again, look for the links I talked about below, during this video, and thank you for watching.